Okay, right back into it. 5.4 and following. Let's see how far we get. So they give us, let's see, calculate the coordinate of t. If QS is 7. Okay, QS is this line over here. And they say that this line is 7 units. Okay, so if that is 7 units, what is the coordinate for t? So you want to find out what's the x value where the difference between the functions are 7 units. Okay, cool. The first thing that we're going to do, right, we're going to check which one's on top. So this one that's on top is our parabola, which is f. The one at the bottom is our straight line. So we're going to take the top one and we're going to subtract the bottom one. And we're going to say when these two get subtracted, their difference is 7. And now we should solve for x. Okay, so let's go do this. So f is x squared minus 2x minus 3 minus g. Now put this in brackets. So this is minus x plus 2. Why must this be in brackets? Because that negative is going to impact everything on the inside, right? And this is all equal to 7. So now it's going to be x squared minus 2x minus 3. This becomes a plus x. This becomes a minus 2. And let's just subtract 7 on both sides already. Minus 7 equals to 0. Now, this should be easy enough. It looks just like a trinomial. Well, in a second. Minus x. That's minus 5 minus 12. And that's equal to 0. Now we're going to solve this. Factorize our trinomial. Again, go put it in the quadratic formula if you can't factorize. That's fine. So I'm going to look at the 12 and I need something that's going to give me a 1. The factors are going to have to be 4 and 3, minus 4 and a positive 3. So this is going to be x is equal to positive 4. And this is going to be x is equal to minus 3. Again, we mentioned that middle step that I didn't show, which was x minus 4 equals to 0. Add that on both sides, so x is equal to positive 4. Okay, great. So these two coordinates, these two x values rather, are where f minus g, so parabola on top minus a straight line at the bottom, will give me 7 units. So there's going to be another point somewhere here, right, where the difference between these two graphs, so somewhere there is also 7. Okay, so obviously we're on the right hand now. So because we're on the right hand side, we're going to take this one. Okay, so the coordinate for t is going to have this x value, and obviously it's on the x-axis, so the y value is 0. Great, that was easy enough. 5.5, they say this over here, find the k value where this has two positive roots. Okay, so whenever you have something like this, they want you to link this to the question that you've been dealing with. Okay, so where did they find this part? Let's forget about the k for a second. Let's take that, and that is x minus 1. This gets squared, and you have this minus 4. What is this? This is your parabola. Okay, so what are we going to do quickly? We're going to see that in a second. We're going to say f of x is equal to a open bracket x minus p close bracket squared plus q. What is this? This is my turning point form of my parabola. The a value is always the same. So whatever a we found here is going to be the same a that we have in our turning point form. So a is 1, x minus, what is the p? So we know that the turning point is our p and our q, right? This is a small p and q. Okay. So p turn is 1. So this needs to be a 1 squared, and q turning point is the minus 4. Right, so this is turning point form of parabola. So if I go back to this question which they gave us, let's go write it down. They said x minus 1 all squared minus 4. That is the parabola that we've got, right? Then they say you're going to have to subtract a certain k value equals to 0, and this has to have two positive roots. Okay, so in order to solve this, I'm going to just open Desmos. So I kept Desmos open fast quickly, and I'm going to go draw that function quickly. Okay. X minus 1, this was squared, and there was a minus 4 here at the back. Okay, so this is the graph that you have, right? So what they want is they want this picture to have real roots, two real roots, right? Two positive real roots. In fact, we do have two real roots, roots of the x-intercepts. So we have this one and this one, but what we can see clearly is the one is negative, the one's positive. How must I shift? So if I'm going to take this and I'm going to add a k, I'm going to plus something, right? That plus something shifts your graph up and down. We should know that. Whatever you add at the end of the whole thing moves the thing up and down. So what must you add or subtract? Let's make it 0 for a second. What must you add or subtract so that this function only touches on the right hand side? So I'm just going to change this k value quickly. And as it goes there, right? So now they're positive. 0 we're going to think of as positive. So here these are positive. And anything above, there's positive. Too far above, okay, they don't have any real roots anymore. So there's the small space where from there up until there, my graph will have two positive values. Okay, so now we need to figure that out. If we go look back at our, let's go back to our graph, okay? So if I look at this now, how far must this move up so that this only goes here? So I know this coordinate. We said this coordinate was -3. So if I take this graph and I move it 3 units up, then it would touch something like that. Are we all okay with that? Right. So let's express that over there. So this k value over here, if that is plus, if this whole thing is +3, then my graph only touches, well, it touches twice, which is what we want. Okay. Right. So we'll say x squared minus 1. Well, okay, the square is not supposed to be there. Let's just get rid of that. Okay. Minus 1 squared minus 4 plus 3. Now, if I need a plus 3 here, I need a minus 3. Okay, so that this can give me that. So my k value is going to be 3. Oh, well, minus 3 at least. So if my graph moves up 3 units, okay, this is equal to 0. If my graph moves up 3 units, I get that where it touches once. Right? If my graph moves up, right, so this point over here is -4. If my graph moves up 4 units, then I'm only going to have it where it touches once. Then it's equal roots. So I don't want it to be bigger than 4, because once it goes up more than 4, then the graph doesn't touch it. So if I say x minus 1 squared minus 4, if I say plus 4 here, right, which is going to be minus my -4, which is my +4. If I do this, this only touches once. So I need to be in between these, my graph to touch twice on the positive side. Okay, so I'm going to say k, it has to be smaller than the -3, but bigger than the -4. Right, so this is where k has to be for our positive side. Let's cut this. I think the video is long enough, and we'll do the last question in the last.